In this lecture, we are going to see about authentication concept. So, what are the requirements for authentication? What are the functions to be followed in authentication? So, these are the topics to be discussed: authentication requirements and functions, MAC, message authentication code, and final one is hash function. So, what is authentication? We all know what is authentication. It is a confirmation about both the source and destination origin of particular information. So these are the following some of the attacks to be identified while performing the transmission or communication between two parties. The first one is disclosure, is nothing but it is the process of releasing of the message content to any third party. Traffic analysis, which is nothing but the frequency analysis is done by the third party to crack the ciphertext. So in connection oriented protocol, the frequency and duration of the connections could be easily determined by the attacker or third party. In either the connection less protocol, the number and the length of the message between parties easily determined or identified by the third party. And some of the attacks, below attacks also identified during the communication. The first one is masked, is nothing but the insertion of the message into the network from the third party source. Content modification, it involved in the process of changes to the content of message. The changes of content of message means we can add or delete or update anything. So the next one is sequence modification. Any modification is done in the sequence of message between sender and receiver, which may be insertion, deletion, or reordering anything. And a timing modification is the delay of the message. The third party got the message from a sender and forward to the receiver at some after some time. So the message is delivered to the receiver is some delay. So this is time modification. So in connection oriented application, the entire sequence of messages could be modified or delayed, but in connection less oriented protocol, the individual single message could be delayed. So the source repudiation is nothing but is the denial of transmission of message by source, and destination repudiation is nothing but denial of receipt of message by destination. So these are the some of the attacks to be identified during communication. So these are all the some of the reasons for going for authentication purpose. So in authentication there are two levels, one is lower level and second one is higher level. In lower level authentication, we can perform some functions which produce an authentication, but in higher level of authentication, which enables the receiver to verify the authentication of the particular message which was sent by the sender. So the function, there are three functions in authentication. The first one is message encryption, second one is message authentication code, that is MAC, MAC, third one is hash function. So in the first slide we see what is authentication and what are the need for authentication, because these are the attacks to be identified: disclosure, traffic analysis, masked word, content modification, sequence modification, timing modification, source repudiation, and destination repudiation. These are the some of the possible attacks to be identified while transforming the message from source to destination. So for that reason only we are going with authentication. So to enable or to perform authentication, we need some functions. The functions are encryption, MAC authentication code, and hash function. We will see one by one. The three functions will be seen in this lecture. The first one is message encryption. We are familiar with encryption. Encryption is the process of converting the given plain text, that is original message, into the ciphertext. Ciphertext is nothing but scrambled code, secret code. So encryption having two types. One is symmetric encryption, second one is asymmetric encryption, is otherwise called as public key encryption. So in symmetric encryption, the message capital M transmitted from source A to destination B, the message is encrypted using the secret key capital K, which was shared by both source and destination A and B. So this is the diagrammatic format of symmetric encryption, which follows confidentiality and authentication. So there are two error control concept here. One is internal error control and second one is external error control. So append an error detecting code, also known as frame. It is a frame format. So the check sequence or checksum, that is FCS, to each before encryption is illustrated in 4.2, that is internal error control. So A is nothing but source. Source prepares some message, capital M, and which provides, this is the input to the function F, the message given to the function capital F. So that produces an focus. Capital F is nothing but focus. So F is a function. That function is applied on the message which produce focus. That is the symbol, double quote symbol. So after that, the focus is appended to M. So you can clearly see that the message M divided in the below part, F of M. So the function is applied on M, and that is appended to the original message M. So the focus is appended to message M, and the entire block is then encrypted by using the key K. Now the encryption process is over, and at the destination part, the capital B, destination, decrypts the incoming block and it treats the results as the message with an appended focus. So here decryption is done with the same key, and the message is appended with focus, that is F of M, and the function is applied on the message, and finally they have to compare the original message with the decrypted message. If both are matched, then only the original message is retrieved from the receiver, that is the sender, that is the acknowledgement is sent to the sender. If the retrieved message is not matched with the original message, then the third party occurred between both sender and receiver. This is the internal error control. So the second diagram is external error control, the same concept, but in the internal error control, the message before the appending process, the message is performing some function to produce focus. But in external error control, initially the message is encrypted by using some key. After that, only the function is applied on encrypted message to produce focus. So this is the main difference between internal error control and external error control. So for the transmission process, we can either using connection oriented protocol or a connectionless protocol. In case if we are using connection oriented protocol, we are following the method TCP or IP protocol, right? Transmission control protocol or internal protocol architecture, because each and every architecture having some format, source port, destination port, checksum value and offset value, flag value. So these are the concept to be required to transmit the message from one source to destination. The message is nothing but is the form of a packet, right? So each and every packet having some information to pass from one port to another port. So this is the format of TCP IP protocol. You can already see that in computer networks. So source port and destination port number, and each and every having sequence number and acknowledgement number and offset value reserved, because some of the bytes to be reserved for future use, and flag value and window. Sliding window protocol, there are some very window protocols, so which protocol to be used here we have to specify, and a checksum value and urgent pointer to point out some of the reversed address, and final one is if the padding concept is needed, we can use it, and final one is application data. So for transmitting purpose, we can using either connection oriented or connectionless protocol. For sample, they are giving a TCP or IP protocol. So in encryption, we saw symmetric encryption. After that, we will see public key encryption, that is asymmetric key encryption. So here three concepts are there. The first one is first diagram. This first diagram provides only confidentiality. So the second diagram provides authentication and signature, and third one is provide confidentiality and authentication. Final one is the combination of the above three. We will see what is that. So in the first diagram, the source A uses the public key value KUB. You know what is KUB? That is public key value of, in the suffix they are giving B. B is nothing but destination. In case they are giving small a, that is the destination key value. So the message is encrypted in the first diagram. The message is encrypted by using the public key value of receiver, destination part. So the receiver decrypt the message by using the private key value of their own. So in this manner, they have maintained only the confidentiality. So we always need both confidentiality and authentication, right? So for that, The message, second diagram, the message is encrypted by using the private key of their own source port, but in receiver part they are decrypting the message to retrieve the original message by using the public key of the sender source side. So for this concept they are maintaining authentication with some signature and confidentiality. And the second last one is they are maintaining confidentiality on the authentication with the signature concept. So initially the message is encrypted using the private key value of source part. Again the message is encrypted by using the value of public key value of the receiver side. This whole concept is known as encryption process. After that the receiver performs the decryption process using the private key value of their own. Then again they are performing the decryption process by using the public key value of the user side. So you can clearly see that the first diagram maintain only confidentiality, the second figure maintain only authentication, but we always need both confidentiality and authentication. So you can clearly see that the first diagram and second diagram there are only one encryption process and one decryption process, but in the third figure you can clearly see that they can perform two encryption process and two decryption process for maintaining both confidentiality and authentication. So this is the process of public key encryption. So the second function of authentication is message authentication code, MAC. So MAC is also known as a cryptographic checksum that is appended to the original message. So this technique assumes that two parties say that capital A and B share a common secret key. When source sends a message to destination, it calculates the MAC value and that is appended with the message by using key value. So MAC is equal to, MAC is nothing but message authentication code is equal to C suffix K of M. So here M is original message, input message, C is the capital C is the MAC function, and K is the shared secret key between source and destination. So the message, original message that is appended with the MAC value which was transmitted to the recipient side. So the recipient performs the same calculation method on the retrieved message using the same secret key to generate the new MAC. So in turns, but that because of the mathematical properties of authentication function, it is less vulnerable to broken than encryption. Here also the authentication confidentiality is maintained by three diagrams for MAC. So the first one is message authentication for confidentiality and authentication. So here also the message is forwarded to some MAC function capital C. So the message is encrypted by using the key value K1, which is passed to the another function. After that only again the same message is encrypted using the another key value. So K1, K2. So you can clearly understand that in message encryption they are using only one key, that is K only used for encryption. The same key value K is used for decryption process. But here MAC concept they are using two key K1 and K2 for encryption process and K1 and K2 value for decryption process. Two key values used for one encryption process. And in decryption part they have to compare the original message with the retrieved message, and finally then only they give the acknowledgement to the sender side. So the third function is hash function. So a variation of message authentication code is the one-way hash function. As with the message authentication code, hash function that accepts variable size message of input and produces fixed size output, that is referred as hash code. What is the meaning of this sentence here? The original message is having any type of length, right? But we have to produce it as fixed size output only. So for that type of code we are using the function is hash function because it accepts variable size length of message but produces only fixed size output. So the hash code is otherwise called as message digest, that is capital M capital D, or hash code. So this diagram clearly explains the concept of hash code. Before that we can know that the process of hash function. So the procedure here summarized as follows. Initially the hash value is set as 0. So the second step is we have to perform my successive n-bit block of data by performing the rotation process of the current hash value to the left side 1 bit, and finally we can perform the XOR operation with the hash value. So in this diagram, the original message is passed with the hash function capital H. In Mac they are giving here capital C. So capital C is the function of Mac and capital H is the function of hash. So again it produced to the focus value, then it is encrypted by using the key value, and finally the message is appended with some message digest, that is nothing but hash code, and which was retrieved by the hash, another hash function capital H, and the final result is always compared with the original result to check whether the input message is sent from the source or another third party. So the same concept is here, but it was little bit different for each confidentiality and authentication, right? So let us we can briefly see about Mac. So before that, the first slide we saw what is authentication, what is the use of authentication, and what is the requirement of authentication, and to establish or to acquire authentication we need some functions, that is message encryption, MAC and hash function. So now let us see the brief concept about MAC and hash function. So the first one is message authentication code. Already we saw it is a form of MAC is equal to C of M. C is MAC function and capital M is input, that is original message, and K is the secret value shared between sender and receiver. So there are some of the requirements for MAC. So in general the MAC function is many to one function. It is not one to many. It is many to one function. Suppose the key value is greater than n, the size is greater than max size, means we have to split into M1 and M2. Here M1 is MAC 1 value and M2 is, and which will go on up to I value, right? So MAC I is equal to C suffix K and MI. So I value can vary from 1 to up to n, small n, whenever K greater than n. So here there are some of the repetitions to be performed. So the round 1, so for round 1 we can perform MAC 1 is equal to CK MI and compute the MAC value for applying 2 power K keys. Similarly we can do for round 2 and up to round n. Number of the values for I we can go with the many round functions, and after that we can perform in the concatenation operator, that is M dash is equal to x1 concatenation x2 and up to xm. And finally after performing that concatenation operation we have to perform the XOR operation between the x value x1 x2 and xm value. So the MAC function should have the following properties. If an opponent observes the message, it should be computationally infeasible to construct the original message, and the C of M should be uniformly distributed. The random messages and M dash probability is C of M is equal to C of M dash. So consider M dash is equal to some known transformation M. So and F is the involved inverting one or more specific bits. So the MAC function is based on DES function, data encryption standard. One of the most widely used MAC referred as the data encryption algorithm is DES. So this is the diagram for DES. So the first block is for the stipulated time, the input bit 64 bit which is given for the DES algorithm encryption process, and finally which give 64 bit ciphertext output. That output is given to the another block of input for another time, and which perform the XOR operation and again performing encryption to produce 64 bit ciphertext. This process is going on until all the plaintext block is processed. So the algorithm can be defined in CBC, that is cipher block chaining mode of operation of DES. So the data to be authenticated or grouped into continuous 64 bit blocks, because here the plaintext blocks is split into several blocks. So finally we have to be grouped all 64 bit blocks. So the last function of authentication is hash function. So the hash value is generated by using the form of small h is equal to capital H of m. Small h is hash value or hash code or message digest, and capital H is the fixed length of hash value, and m is the variable length message. M is variable length message is input by applying hash function on this variable length message to produce the fixed size hash value, that is small h, hash code or hash value or message digest. So this hash value is appended to the original message at the source when the message is assumed or known to be correct. So the receiver authenticates the message by recomputing the hash value, because the hash function is not considered to be secret because it is known to everyone. So the hash function is performed by any third party to retrieve the hash value. So some of the requirements of hash function. The first one is hash function can be applied block of data of any size. Already we saw that, because the input size is any length of the message. So the requirement is the hash function can be applied to any size of block of input. But second one, it produces only fixed size output, right? H produce only fixed size output. And third requirement is h of x, hash value of the particular input is easy to compute for any given value of x, making both hardware and software. This is the third property or third requirement. And fourth one is, for any given value h, it is infeasible to find that h of x is equal to h. This property is called as one-way property. And fifth one is, for any given block, it is infeasible to find y does not is equal to x with h of y is equal to h of x. This property is known as weak collision resistance. And last one is strong collision resistance. It is also infeasible to find such that h of x is equal to h of y. This process is called as strong collision resistance. So whenever y is not equal to x, we can't easily find the value of h of y is equal to h of x. So this is infeasible. This property is known as weak collision resistance. So again, same concept, h of is equal to h of y. For any pair x comma y, it is very difficult or hard to find the value for x and y. So this property is known as strong collision resistance. And also the fourth one is one-way property. It is infeasible to find the value of x. For example, if they are giving h value, by using small h value, how we can find the value of x? It is very difficult to find the value of x for the given value of h. So this is also infeasible to find. This property is known as one-way property. So the first three properties or requirements for practical application of hash function. Fourth property is one-way. It is easy to generate the code for the given message. And fifth property, give the guarantee like the alternative message having for hashing value of some other value which is not found. And the last property refers to how resistant the hash function is to class of attack known as birthday attack. So these are some important points of hash function. So it has the formula of h is equal to h of m. So it take any variable length of messages input, but it produce only fixed size of output. And some of the 6 properties are there. First one is variable size input. Second one is fixed size output. Third one is it is easy to compute for any value. For example, you have to find h of x. If they given the value of x, then you can easily find the value for h of x. So this is the third property. Fourth one is if they are giving the value for h, but you can find the value for x from h of x is equal to h. It is infeasible to find. This is one-way property. And fifth one is weak collision. For the pair of y is not equal to x, but you have to find the value for h of y is equal to h of x. It is also infeasible, that is weak collision resistance. Final one is for any kind of pair h of x is equal to h of y, you can find the pair value of x comma y. It is very difficult because there are multiple values for x and y. How can we find the value for x and y? It is infeasible to find. This property is known as strong collision resistance. So there is one function for hash to produce a hash value or hash code. So all the hash function operates the following some principles. So the input message is sequence of blocks, that is message or files, etc. So the input is processed one block at a time in an iterative manner to produce the hash function. So one of the simplest hash function is exclusive XOR operation, bit by bit XOR operation. So the final output Ci, ith bit of hash code is equal to Bi1. B refer to the block. So Bi1 is the first block, Bi2 is the second block, and that symbol plus is XOR operation performed on all individual block, and finally we concatenated all other ciphertext block to produce the final plaintext value, right? So this is the format for we can split into the input into block by block. So the first block we can split the first block B11, that is first block, and the second block and fourth block and goes and so on. Similarly we can do it for all blocks, and each block value is splitted up by bit, and finally we can perform the hash function to produce the hash code, that is C1 up to Cn. So here clearly see that C1 is equal to Bi1, that is C1 is equal to B11 XOR operation B12 XOR operation B1. Similarly C2 is equal to B21 XOR operation B22 XOR operation B2m, is so on, right? So hash function is performed by using simple bitwise XOR operation. So this is the format of performing of XOR operation, because here we can split the block into 16 bit. So the right hand side box represents there are 16 bit block size. So in the left hand side the XOR with 16 bit to the right side rotation. So you can clearly see that. So for the right hand side diagram, the last box is simulated to the left hand side leftmost box, which means they are performing the right side rotation. So for performing the right side rotation, the last bit is which goes to the first bit of the second input, right? So that they are simulating the last box value of the rightmost diagram with leftmost bit of the leftmost diagram, right? And finally they can perform the XOR operation. These all are the formulas of XOR operation for each and every individual bits. So here one attack is that is birthday attack. This attack having 64-bit hash value, which is secure, and which is performed works by the following steps. The first one is the user prepared to sign a valid message, and the opponent, that is destination, generates 2 power m by 2. M means the original message variations with the same meaning and save them. And the next opponent also generates 2 power m by 2 variations of the y value. So here two sets of messages compared to find the pair with the same hash. Here only one sender is there, but the receiver is more. So after getting the message, the first opponent generates 2 power m by 2 variations to find out the ciphertext, and simultaneously another receiver performing 2 power m by 2 variations to retrieve the original text. So the block chaining technique is nothing but already we saw in the previous slide. The MAC following the concept of block chaining modes of operation of disk. So the same concept here. They are using the block chaining method. So the given original message can be divided into fixed number of blocks, that is M1, M2 and Mn, which is based on data encryption standard algorithm, and following the method of CBC, cipher block chaining technique. So the final one is security of hash functions and MAC. So what are the attacks to be performed on hash function and MAC? There are two attacks. One is brute force attack and second one is cryptanalysis. In generally brute force attacks is nothing but they are trying all possible combinations of input to crack the ciphertext, and cryptanalysis is nothing but the third party trying to break the secret code ciphertext without knowing the key value. So here also the brute force attack, they are choosing the concept of hash function. So the strength of hash function is nothing but one-way property, weak collision resistant and strong collision resistant, because it is very difficult to find the value for h of x is equal to h, and h of y is equal to h of x, and h of x is equal to h of y. So the strength of hash function against brute force attack is depending on the three properties: one way, weak collision and strong collision. So for MAC authentication code, a brute force attack on MAC is more difficult because in MAC they are performing some MAC value that is appended to the original message. So for brute force attack they are trying all possible combinations, but it is very difficult to find that particular original value for message authentication code. So these are some of the questions in this lecture. Authentication functions are message encryption, MAC message authentication code, and final function is hash function. So what is MAC? It is some value that is appended to the original message, right? What are the requirements of hash function? There are 6 requirements, right? The first requirement is it accepts variable length message, but the second requirement is it produces only fixed size output. Third one is we can easily find the value for x for h of x. Third one is fourth one is weak collision resistant and strong collision resistant, and one weak property, right? One way property. And what is the use of hash function? It is also small h is equal to capital H of x, here capital H of m. M is the original message and h is the hash function to be applied on the original message to produce the hash code, which is also appended to the original message. And final one is list of authentication requirements. There are some of the requirements are there to produce authentication, that is mask word and sequence modification, content modification, source and destination repudiation, and disclosure, traffic analysis. These are the reasons we are going for authentication.